I'm going to answer this question asked by a student. Two cyclists leave a city at the same time, one going east, the other going west. The westbound cyclist bikes at 6 miles per hour faster than the eastbound cyclist. After 4 hours, they are 144 miles apart. How fast is each cyclist riding? That's the question. So I'm going to let X represent the question. How fast is the speed? So I'm going to let X be the speed. So X is going to be the speed of the cyclist, and there's one going east and one going west. So I'm choosing one. I'm going to choose the one riding east. Okay. So we also have the speed of the cyclist riding west. That is also an unknown, and if you notice, they ask that question also. So we don't want to do y. Actually, if you did y, that would be Chapter 4 method. But Chapter 2 method, you need to have one variable, so we need in terms of x. And it tells you that the west cyclist, that's why I chose east, because it said the west is 6 miles per hour faster than the east. So what would this be? Whatever this one is, plus 6. So now we have an expression for both of our questions. We do that for all word problems. Okay, now, what's special about this one is this is a distance, a motion problem. So we're going to use the distance formula, d equals rt, where d represents the distance, r represents the rate, and t represents the time. Now, since there's 3 variables going on there are 3 quantities, distance, rate, and time, I like to use a chart whenever I'm using a distance problem to organize my thoughts. Okay, so here's the chart that I'm going to use. It's always using the formula over here on the right. R, T, and D. I always put D on the right because D is the very right-hand one because D is alone over here. Solve for D, the equation is. And then since there's an east and west, that's why I put the east and the west. Okay, the rates. Well, if you notice, X represents, so what I'm going to do, actually, I'm going to try to fill out these 4 and then use my formula for these 2. So X represents, right, that's what I have, the quantity for the speed of the east is x. The quantity for the speed, the rate of the, which is the same as speed, by the way. The quantity for the rate of the west is x plus 6. Okay, the times. Do they give you the times? Oh, after 4 hours. So the time of the east is 4. It's not total. After 4 hours, they are. So he goes 4 hours, the east and the west. Okay, now to fill out these, I'm not going to try to do that from the words. I'm going to use my formula for this. This equals r times t. So this would be 4 times x. This would be 4 times the quantity x plus 6. So now I have an expression for the distance of the east and an expression for the distance of the west. I'm going to finally use the final quantity they have not used, that the total distance are 144 miles apart. Sometimes it's helpful to draw a picture. We have west here, east over here. They start here. 2 cyclists leave a city at the same time. One is going east, while the other one's going west. The one going west is 6 miles per hour faster than the one going east. And after 4 hours, they're 144 miles apart. So this distance, this total distance right here, is 144. So what does that mean? That the distance of the east plus the distance of the west equals 144. That is the equation. Again, you can see I have the distance of the east plus the distance of the west is 144, and one distance of the east is 4x. The distance of the west equals 144. How do you solve that equation? Well, you use the distributive property. Combine like terms. Subtract 24 from both sides. divide by both sides by 8. So that gives us the x, which is the east. So the answer for the east, this one, is 15 miles per hour. How do you find the west? Well, we know that the west was equal to x plus 6. So we take that 15 and we add 6, and we get 21. So the answer to the one writing west is 21 miles per hour. That is how you solve this word problem.